All right, if you're studying for your technician exam, you have come to the right place. In the next few minutes, we're going to break down the essential maintenance concepts you absolutely have to know. Our goal here is to get you ready to ace that test.
So let's start with a big picture question. Imagine this: a critical piece of equipment fails. Now what? Well, it's not chaos. There's actually a very precise, structured system for getting that gear back online. And your job is to know exactly where you fit in.
And here's our game plan. We're going to start with the why, then dive into the 3 levels of maintenance, cover the different kinds of work you'll actually do, and we'll even get into some of the nitty-gritty stuff like EMI and the 2M program. So let's just jump right in.
First things first, why is this so important? Well, maintenance isn't just about tinkering with machines. It's a highly organized system designed to make sure equipment is ready to go when it is needed most. Because let's face it, when a system fails at the wrong time, the consequences can be enormous. The real goal here is to prevent those failures from ever happening in the first place.
And this point gets hammered home in the NavC source material. The systems you're going to work on are unbelievably complex. And what that really means is that the entire system depends on you. Your training, your supervision, and your availability. You are the critical piece of the puzzle.
So, how is all this work actually organized? Let's get into our first major concept, a 3-tiered system that structures every single maintenance action. You really got to understand these levels, because they tell you exactly who does what and where they do it.
The easiest way to think about it is like a pyramid. At the base, you have the most common, everyday tasks. And as you move up that pyramid, the jobs get more and more complex, needing more specialized skills and equipment. Let's break down each one.
Okay, first up is organizational maintenance. This is the front line. This is your world. It's all the hands-on, day-to-day work that you, the operator, perform on your own gear. For instance, when you do your daily checks and clean out the filters on a radar console, yep, that's organizational maintenance. But what happens when a problem is just too complicated to fix right there on the spot? Well, that's when it goes up to the next level, intermediate maintenance. This is for work that's beyond an operator's scope. It's handled by special support groups, like a shipboard electronics shop. A perfect example is if you pull a faulty circuit card from your radar and take it to that shop to get a single component replaced.
And right at the top of that pyramid, we've got depot maintenance. This is the big stuff, the highest level of repair you can get. We're basically talking a full factory overhaul. This is for major rebuilds and system modernizations. For example, sending an entire radar system to a naval shipyard for a complete refit, that's depot-level work.
Okay, so we've covered the where, those 3 levels. Now let's dig into the what. What kind of work are you actually doing within those levels? This is all about the what and the why behind every action you take.
Operational maintenance is pretty straightforward. It's all about that routine care you provide as an operator, and it ties directly back to that organizational level we just talked about. This is you using your system knowledge to keep things running smoothly with cleaning, servicing, that sort of thing.
Now, what's really cool about this next one is its whole philosophy. Preventive maintenance is all about being proactive, not reactive. You can think of it like finding and fixing a tiny little crack before it has a chance to become a massive break. The entire goal is to stop equipment from failing before it ever happens.
And finally, we have technical maintenance, which you also hear called corrective maintenance. So, if preventive is proactive, this one is reactive. This is that classic break-fix job. A system is down, and it's going to take some serious technical skill to figure out what's wrong and bring it back online.
All right, let's switch gears and talk about a problem that affects all electronics, especially on a ship. And that's electromagnetic interference, or EMI. Think of it like the static you'd hear on an old radio, but it's affecting your most critical equipment. It's this invisible electrical noise that can cause all sorts of chaos. So what is it exactly? Well, EMI is just any electromagnetic disturbance that messes with your gear and causes it to malfunction. And on a ship that is packed to the gills with powerful transmitters, motors, and electronics, yeah, managing EMI is a constant battle.
Now, this interference comes from 2 main places. First, you've got natural sources, things like lightning or solar flares, which, are completely out of our control. But then you have all the man-made sources, all the transmitters, welders, and motors on a ship. Learning how to manage these is a huge part of your job.
But the good news is, we're not helpless here. There are 5 basic methods you'll use to control EMI on a ship, thinking about equipment location, using proper shielding, good system grounding, careful management of your cables, and making sure you have a clean power source.
And finally, let's touch on a very specific, highly advanced type of repair. You know how all electronics are getting smaller and more complex? Well, that means we need new ways to fix them. And that's exactly where the 2M program comes into play.
The 2M program, that stands for Miniature/Micro-Miniature, gives us the specialized training and the tools to repair really complex circuit boards. And this is a huge deal because it saves an incredible amount of money. We're fixing tiny components instead of throwing away entire expensive modules, and that directly improves fleet readiness.
Whew, okay. We've covered a ton of ground in a really short time. To make sure it all sticks, let's do a super quick recap of the key terms before we run through a few practice questions to see what you've learned.
Okay, rapid fire time. Organizational, that's you on the front line. Intermediate, that's the specialized repair shop. Depot, think major factory overhaul. Preventive is proactive, you're stopping failures before they happen. Corrective is reactive, fixing what's already broken. E&I is that nasty, unwanted electrical noise. And the 2M program is for fixing those tiny, complex circuit cards. Got it? Let's test it. All right, first question for you. If a whole system needs a complete rebuild at a shipyard, which level of maintenance is that? If you said depot maintenance, you are exactly right. That's the highest level, the big one.
Okay, next up, what's the main point, the primary goal of preventative maintenance? It's all about detecting and correcting those minor faults before they can cause a major failure. It's all about being proactive.
And for our last slide, here's some food for thought. As our equipment gets more and more automated, which one of these maintenance types do you think will become the most important for making sure everything stays reliable? There's no single right answer here, but thinking about it will help you connect these ideas to the real world. Keep studying, you're on the right track.